Moving on now to weathering rate. How fast does something weather? So this is Roman numeral number 2 under section 2, surface processes, in our geology notes. So we're on page 29 of the green notebook. You can see that we're going to be focusing on weathering rate, which is how fast rock can be broken apart. There are 3 factors that affect the weathering rate. The first factor is going to be the surface area. As rocks break apart into smaller pieces, more of that rock is then going to be on the surface. More of that rock is going to be weathered by the water, the acid, by some ice getting into cracks. We can see an example of that here. I've got a tablet, an antacid tablet that's whole, and then another one that's been broken up. So it's the same mass between the two. It's the same amount, the same volume between the two. But when I drop them into some water and move them around and wiggle them around, the antacid that was broken into pieces is weathering faster than the other one, than the one that was whole. There's barely any pieces left in there, yet I could still see the whole piece fizzing in there. So the smaller broken pieces weathers faster than the one large piece. It takes a longer time for this one to dissolve. This was broken in pieces. It has a greater surface area. The amount of material is the same. That hasn't changed. What has changed is the surface area of the material. We could see in our notes on page 29, if we look at this box right here, it has a side that's 3, let's say that's 3 inches. And if that's 3 inches there, then we know that the surface area of one side is going to be a total of 9 square inches. And there's a total of 6 sides. So that gives us 54 square inches is the total surface area of this block. Now here we have the same amount. We've just taken this block and we've broken it up. So it's the same amount of material. It's just now broken into different pieces. If we take 1.5 by 1.5, we're going to get a square of 2.25 square inches for that, which means each of these little boxes here is going to have a total surface area of 13.5, but there's 8 of them on here. So that gives us a total of 108 square inches of surface area. So the surface area is increased to 108. If we break this up even further, if we take each one of these, now that it's 1 by, I've got a total surface area in each one of these entire blocks as 6, it adds up to a total of 162 square inches. It's the same amount of material between the first block and this one here, all these blocks. It's the same amount, same volume, same density, same mass, but we've increased the surface area. As you increase the surface area, you're going to increase the weathering rate, meaning how fast it happens. Remember, rate is how fast something happens. So we're increasing the weathering rate by increasing the surface area. The next factor that affects weathering rate, or how fast something weathers, is the composition. What is the rock made out of? So here you can see in this diagram these people standing under a rock. This was once all rock. This entire area is once completely rock. The rock at the top, notice, is a different color than the rock at the bottom. So we have 2 different types of rock. This rock here is weathering our way faster than this rock. Now, eventually it's going to weather away to the point where this is going to fall down. But we can see how this rock weathers faster, and that's because it's made out of a different material. Whenever we see outcroppings, or where we see rocks sticking out of the ground, we can see this happening. We could also see this just on some rocks that we have on some hand samples, like this one right here. So here's this rock. We can see it's got some layers. It's a sedimentary rock, But this layer in particular has not broken down as fast as these other layers. And so it sticks out all around that rock. Why? Because this rock is more resistant to being weathered. It's a stronger rock, so it's going to weather slower. Some rocks are made out of softer minerals, so they're going to weather faster. Here you can see an entire layer of rock that was weathered faster than other layers of rock. These pictures are from Arches National Park in Utah. And this happens because some rock weathers faster than other rock. Therefore, it's going to weather away and be gone, where the stronger rock weathers slower, therefore it's going to stick around. We could also see this on gravestones. Both of these gravestones were erected in 1888. So here you could see October 18th, 1888, William Mathers. Over here, a little bit difficult to read, but over here you might be able to make out 1888. The one on the right has been weathered much more than the one on the left, and that's because of what it is made out of. The one on the left is made out of an igneous rock, diorite, or a granite. The one on the right is made out of limestone. So over the last 130 plus years, this rock here that is made out of a granite, which has feldspar and quartz, which have hardnesses of 6 and 7 respectively, is going to weather slower than the gravestone made out of limestone. And remember, limestone is made out of calcite. Calcite, we can see, has a hardness of only 3. Therefore, it's going to weather a lot faster. Composition of the rock is going to cause rocks to weather faster or slower than other rocks. And finally, the third factor is the climate that the rock is in will affect how fast it weathers. So here we have a picture of an obelisk. We can see ancient Egyptian hieroglyphics written on here. One of these obelisks was taken from Egypt and brought to New York City. You can go to New York City now and go find Cleopatra's Needle is what it's called. When you look closely at this Cleopatra's Needle, it is well worn. Yet, when we look at one that is still in Egypt, we could see how well the hieroglyphics still show up. Over 3,000 years, this obelisk has been around, the one on the left, and we could still clearly read the hieroglyphics. Yet this one on the right, which was brought to New York City and had been there only for a few dozen years, is much more weathered away than the other one. Why? Because of the climate that the obelisk was sitting in. So climate will have an effect on how fast rocks weather. It will also have an effect on how the land looks. If the climate of an area is very dry, we will get weathering that gives us rocks with nice angular changes from one rock layer to another. But if we have a climate that is warm and moist, there's much more gentle slopes because of the vegetation there. So we have our third factor that affects the weathering rate, or how fast rocks weather, and that's going to be climate. Chemical weathering in particular is going to happen much more and faster in hot and wet climates. This is no surprise, since when we talked about chemical weathering, we talked about how water, carbon dioxide mixed with water, and oxygen cause most of the chemical weathering. That's going to happen more in a hot, wet climate.